Now here's the last lesson for chapter 10. We're going to call this 10.4, day 2, and I want to show you a couple examples where we may see some problems that look like we need to apply a double angle or a sum and difference formula, but we actually don't want to. Okay? For example, if I were to treat this like the ones we saw the other day, I'd substitute right here, and we'd have 2 sine of x times cosine of x equals 1. Okay? This is a bad idea. And what's going on here is you can see that we started with an equation in terms of sine, and then I made a substitution with the double angle formula. And sure, that double angle is gone, but I now have an equation that's in terms of sine and cosine, which most of the time, there's actually one problem in the homework where it happens and it's okay. But most of the time, this is no good. I don't want that. Okay? Instead, if I were to divide by 2, I would have sine of 2x equals a half. And at this point, I could just go ahead and take the inverse sine of 1/2, and I can deal with this 2x after I take the inverse. It's not going to be a huge deal. 1/2 is a key point that shows up on the unit circle. 30 degrees. Okay, the instructions make it clear here that I'm working in degrees. Or really shouldn't say or there. A more appropriate way would be to say and 2x equals 150 degrees. Okay. Now I can just simply proceed and divide by 2. X equals 15 degrees. That'll be a solution. Same thing here. Divide by 2, and x equals 75 degrees. And it looks pretty darn good. Okay, handled that just fine. Okay. If we think back to the sine and cosine graphs that we worked on in chapter 8, we know that that 2x has an impact on the graph. As a matter of fact, it has a very specific effect. It changes the period. That's our value for b, and a sine curve's period is 360 degrees divided by b, which means this graph is going to repeat every 180 degrees. Well, for solving this equation, that also means that's how often solutions are going to start to repeat. So really, to each one of these, I should tag on. If I wanted to find other solutions, I could add or subtract 180 degrees. Well, the instructions here say to solve it from 0 to 360. So I at least need to check and see if there are other solutions that come from adding the period of this graph. And I can indeed find 2 more. 195 degrees, that's a solution, and it's between 0 and 360. Over here I add 180 and I get 225, and that would be another solution. Okay, if you were to continue to add 180 degrees, you'd see that that takes us outside of our interval of 360. Okay, something to check. Important to do that. Okay. A little bit different here, though, as applying a double angle formula was not something we wanted to do. Likewise, on this one, it might be tempting to look right here and say, hey, let's apply a sum formula. We can take that part in parentheses and rewrite that as cosine of x times the cosine of 45 plus the sine of x times the sine of 45, and that all equals 1. Okay? What a mess. What a mess. Likewise, bad idea. Okay? Really for the same reason that I had one trig function and now I made it two, which is not cool. Okay? It's something I'd like to avoid if I can. Instead, dividing by 2 is a much better start. And we end up with that. Cosine of x plus 45 degrees equals a half. And once again, I can move to that next step of taking the inverse. This is also dealing with key points on the unit circle. Inverse cosine of 1/2, if I'm dealing with degrees, would be 60. And 120. This leaves us with a couple rather simple equations to solve. (15 degrees) whoops, hold up here. I better double check my unit circle, shouldn't I? There's a 120. 300. Okay, I wasn't looking right at all. What I was doing there is I was doing this without the unit circle, and I was applying our little rules to generate a second solution from the inverse. And what I had done in my head was done 180 minus my first answer. That's the rule for sine. That's where I got myself in trouble there. For cosine, it's 360 minus our first answer. Okay? Important to keep those rules straight. 225, that would be solution number 2. And we should check here to see if there's other solutions. And although this graph has been shifted horizontally, the period hasn't been changed. Okay, nothing has been multiplied with x, which means it's 360. I've got my two solutions, and when that's the case and the period hasn't been changed, I can get a maximum of 2. So these are the only two, and that's all. So use some discretion when you're solving trig equations that could potentially involve a sum formula, a difference formula, or a double angle. It's not an automatic that we want to do it. If it makes the equation more complicated, particularly if it increases the number of trig functions you have, don't do it. Double check to see if you can solve it without it. Many times you'll be able to.